Hello everyone and welcome back to a new lesson. In this video, we're going to study one of the most important ideas in circular motion, the force that maintains circular motion. Now let's start with a simple example. Imagine a ball tied to a string and moving in a horizontal circular path at a constant speed. The ball has a tangential velocity which is directed along the tangent to the circular path. But remember, even though the ball's speed is constant, its velocity is continuously changing. Because of this change in direction, the ball experiences centripetal acceleration, which is directed toward the center of this circular path. Now there is something important we need to understand. The ball has inertia. Its inertia tends to keep it moving in a straight line rather than following the path. But the string exerts a force on the ball, pulling it toward the center. This inward force changes the direction of the ball's velocity and keeps the ball moving in a circular path. So the net force directed toward the center of the circular path is called centripetal force, and it is the force that maintains the object's circular motion. To define it, we're going to say centripetal force is the resultant effective force on a body that moves it in a circular path and is directed towards the center of that circular path. To calculate centripetal force, we use these following equations. Fc is equal to m multiplied by as. M is mass, be careful, and ac is centripetal acceleration. Fc is equal to mvt squared divided by r. Fc is equal to m multiplied by radius multiplied by omega squared. You can use one of these equations to calculate centripetal force. Centripetal force depends on the mass of the object. A greater mass requires a greater centripetal force for the same circular motion. And it also depends on tangential or linear speed of the object, Vt. Notice that the speed is squared in the equation. That means that increasing the tangential speed has a strong effect on the centripetal force. It also depends on the radius of the circular path or the distance from the axis of rotation. So remember, an object doesn't move in a circle because it has centripetal acceleration. There must be a net force toward the center of that circular path to produce that acceleration. Remember, centripetal force is the force that causes circular motion. For an object to keep on its circular path, centripetal force is necessary, and the angle between centripetal acceleration and centripetal force is 0, AC and FC. The angle between tangential and centripetal force is 90 degrees. They are perpendicular. The angle between tangential speed and centripetal force is 90 degrees. There is a really easy way to remember this. You see, whenever you have tangential and centripetal, it's going to be perpendicular. Whenever you have tangential and tangential, it's going to be parallel, or the angle is going to be 0. For example, look at centripetal acceleration with centripetal force. It's the same, centripetal and centripetal, so the angle is 0. But look at tangential acceleration and centripetal force. You have tangential and you have centripetal, so the angle is going to be 90 degrees. This is a really easy way to remember. Now take a look at the following questions and see if you can solve them. Now let's solve a few questions. We have sample problem 1H. A pilot is flying a small plane 30 meters per second, so that is Vt, in a circular path with a radius of 100 meters, that is R. If a force of 635 Newton is needed to maintain the pilot's circular motion, so that is Fc, which is 635 Newton. What is the pilot's mass? Now, before you solve this question, you have to know which equation to use, or sometimes students are going to be confused on what equation to use. So remember the three equations we had. Fc is equal to m multiplied by AC. Fc is equal to m multiplied by Vt squared divided by r. We have Fc, which is equal to mass times radius times omega squared. So you see here it mentions Vt. So you have to use an equation which has Vt in it. So we're going to use this equation. Fc is equal to mvt squared divided by r. Since you are trying to find the mass, so you have to flatten the equation. So Fc multiplied by the radius, and then we have m mvt squared. This is going to be mvt squared is equal to fc multiplied by r. You're trying to find mass, so divide both sides by mass. Mass is equal to fc multiplied by r divided by vt squared. Just apply the numbers that you have. So mass is equal to fc is 635 multiplied by r is 100 divided by vt is 30, so that is going to be 30 squared. Calculated and you're going to get 70.6 kilogram. We have practice 1H. A girl sits in a tire that is attached to an overchanging tree limb by a rope of 2.1 meter in length. So that is R. The girl's father pushes her with a tangential speed of 2.5 meter per second. So Vt is 2.5 meter per second. If the magnitude of the force that maintains a circular motion is 88 Newton, so Fc is equal to 88. What is the girl's mass? So we're going to use the same equation. You know how to rearrange that. So mass is going to be Fc multiplied by radius divided by Vt squared. Just apply the numbers you have. That is 88 times 2.1 divided by 2.5 squared. That is going to be 29.57 kilogram. We have question 2, which has a somehow strange idea. We have a 905 kilogram test car travels around a 3.25 kilometer circular track. So mass is equal to 905 kilogram. And be careful, most students are going to be confused with that 3.25 kilogram, or they are going to just write radius is equal to 3.25. It says travels around. It doesn't say that the length or the distance from the axis is 3.25 kilometer. It says the circular track has a distance of 3.25 kilometer. So the circumference is equal to 3.25 kilometer. Change that to kilometer, that is going to be 3,250 meters. If the magnitude of the force that maintains the car's circular motion is 2,140, so Fc is equal to 2,140 Newton. What is the car's tangential speed? So Vt is equal to what? I told you, because it's talking about tangential speed, so you have to use an equation that has tangential speed. So Fc is equal to mvt squared divided by r. Since you are trying to find Vt, so the equation is going to be like this. mvt squared is equal to Fc multiplied by r. So divide both sides by mass. Vt squared is going to be Fc multiplied by r divided by the mass. Now, before you solve the question, you have to first find the radius. Why? Because we need it in the equation and we only have the circumference of the circular track. Now you know that the circumference of a circle is equal to 2 pi r. We have circumference and we need to find r. So divide both sides by 2 pi. R is equal to c divided by 2 pi. Now r is equal to circumference is 3,250 divided by 2 pi. Calculated and you're going to get 517.5 meters. Now just apply the numbers in the equation. So Vt squared is going to be 2,140 multiplied by 517.5 divided by 905. Vt squared is going to be 1,223.701. Take the square root for both sides and you're going to get 34.98 or approximately 35 meter per second. Now take a look at the following question and see if you can solve it. Just remember that 3.14 kilometer is circumference. We have question 26 from chapter review. It says a roller coaster car speeds down a hill past point A, then rolls up a hill past point B. The car has a speed of 20 meters per second. That means this is Vt at point A. Be careful. If the resultant force on the car is 2.06 times 10 to the power 4 Newton, that is Fc, and is directed toward the center, what is the mass of the car? That is A. If you look at A, you're going to see that it tells you that the radius is 10. So you have to write that down. Radius for A is equal to 10. Part A of the question, it says, what is the mass of the car? So since we have tangential velocity, so use an equation that has tangential velocity. So Fc is equal to mvt squared divided by r. Now you are trying to find mass, so mass multiplied by Vt squared is equal to Fc multiplied by r. Divide both sides by Vt squared, so mass is equal to Fc multiplied by r divided by Vt squared. Now just simply plug in the values you have. So mass is equal to 2.06 times 10 to the power 4 times radius, which is 10, divided by Vt squared, which is going to be 20 squared. Calculated and you're going to get 515 kilogram. Now part B is a new idea. It says what is the maximum speed that the car can have at point B for the gravitational force to hold it on the track. Now we know that for part B radius is equal to 15, and you also have to remember that Fc is equal to Fg here. Why? Because it says at point B for the gravitational force only to hold it back. impact. Okay, so here Fc is going to be equal to Fg. You know that Fc is equal to mvt squared divided by r, and Fg is equal to, what you have studied this, is equal to mass times gravity. Now the two masses cancel each other. What you are left with is Vt squared divided by r is equal to gravity. Now you are trying to find Vt for part B. So Vt squared is equal to r multiplied by g. Now just simply plug in the values you have. Vt squared is going to be 15 times 9.81. That is going to be 147.15. But don't forget to take the square root. So that is going to be 12.1 meter per second. Now take a look at this question, and it is similar to the one we solved before. We have question 29, chapter review. An airplane is flying in a horizontal circle at a speed of 105 meter per second. That is Vt. The 80 kilogram pilot, that is mass of the pilot, doesn't want the centripetal acceleration to exceed 7 times free fall acceleration. Free fall means gravity. And it says that the pilot doesn't want the centripetal acceleration to exceed 7 times. So what does that mean? That means AC is equal to 7g, okay? Now 7 times, gravity is 9.81. That is going to be 68.67 meter per second squared. Part A of the question says, find the minimum radius of the plane's path. So radius is equal to what? Now, use the equation for centripetal acceleration to find the radius. AC is equal to Vt squared divided by r. Now, why do we use this equation? Because we have Vt and we have AC. So you can find the radius. Radius is going to be Vt squared divided by AC. Vt is 105, so that is going to be 105 squared divided by 68.67. Calculated, and you're going to get 160.55, and that is approximately 161 meter. For part B, it says, at this radius, what is the net force that maintains circular motion on the pilot by the seat belts, the friction against the seat, and so forth? So it's asking for Fc. And how do you know which equation to use? You have Vt, you have the radius, you have the mass. You can either use both of these equations. Fc is equal to mvt squared divided by r, or you can use Fc is equal to m times centripetal acceleration. It doesn't matter which one you use, since you have all the givens for those equations. Fc is equal to mac, that is what equation I'm going to use. M is 80 times, AC is 68.67, and that is going to be 5.49 times 10 to the power of 3 Newton. For the following questions, you're going to be needing these two notes. First, for objects moving in a circular path on a flat surface, static friction Fs provides the inward force to maintain circular motion. For example, car turning on a flat road or a block on a rotating turntable. Now you studied in grade 11 that μs, or coefficient of static friction, is equal to Fs divided by Fn. Now we said that static friction, or Fs, will be the inward force needed to maintain circular motion. So you have to replace Fs with Fc and Fn with Fg. So what we are left with is Fc divided by Fg, and Fc is equal to m multiplied by AC, and Fg is m multiplied by g. Now the two masses cancel. You are left with μs, which is equal to AC divided by g. Now there are two ways you can express this equation. You studied that we have two equations to calculate centripetal acceleration, or AC, which were AC is equal to Vt squared divided by r, and AC was equal to omega squared multiplied by r. So instead of writing AC, you can write either of these two equations, but depending on the question, they will be different. So you can write μs is equal to v squared divided by rg, or μs is equal to omega squared multiplied by r divided by g. The second note is, when an object is pressed against a circular wall, the normal force, or Fn, from the wall provides the centripetal force. In a rotating cylinder ride, static friction acts upward to prevent the rider from sliding, while the normal force keeps the rider moving in a circular path. Example of this is rotating amusement park cylinder ride. Now, again, we have the equation for coefficient of static friction. So μs is equal to Fs divided by Fn. We said that this time normal force, or Fn, will be the centripetal force. So we're going to say, instead of writing Fs, we're going to write Fg this time. And instead of writing Fn, we're going to write Fc. Fg is equal to mg, and Fc is equal to m multiplied by AC. The two masses cancel. What you are left with is μs is equal to g divided by AC. Again, we have two equations equations for AC, you can write them depending on the question or what the question asks. You have to take that into consideration. Now, mu s is equal to r multiplied by g divided by v squared. Mu s is equal to g divided by omega squared multiplied by r. Before solving the following questions, you have to know these notes. You can also do something, which is memorize the final equation, or memorize mu s is equal to AC divided by g for an object moving on a flat surface, or you can memorize mu s is equal to g divided by AC for a rotating cylinder, right? Now let's take a few examples about. We have question 33 from chapter review. It says a 13,500 Newton car traveling at 50 km per hour. That is Fg, which is 13,500 Newton, and 50 km per hour is Vt. Round a curve of radius 2 times 10 to the power of 2. So that is r. A, it says the centripetal acceleration of the car. So you have to find AC. Now let's find AC. AC is going to be Vt squared divided by r. We have to use this equation because we have Vt and we have the radius. We don't have angular speed, so you can use the other equation. Now before you continue solving the question, you have to change 50 km per hour to meter per second. You can do that in two ways. You can divide 50 by 3.6 and you get 13.9, or you can do this one too. It's also correct. 50 times right kilometer per hour, and you have 1000 instead of the kilometer, and instead of hour you have 3600 seconds. Calculated, and you're gonna get 13.9 meter per second. Now AC Vt squared divided by r. Vt is 13.9 squared, and we have r, which is 2 times 10 to the power of 2, calculated, and you're gonna get 0.965 meter per second. Part B of the question says the minimum coefficient of static friction between the tires and the road that will allow the car to turn safely. Now, because it's a car and it is moving on a flat surface around a circle, so you have to use this equation. Mu s is equal to AC divided by g. Now we found AC, which is 0.965, and gravity is 9.8. That is going to be 0.098 and approximately 0.1. Now take a look at the following questions. They're very similar to what you have solved now. Take a look at them and solve them, and then compare your solution with mine. We have question 34 from chapter review. It says a 2 times 10 to the power of 3 kilogram, that is mass, car rounds a circular turn of radius 20 meter. So that is radius. If the road is flat, that means we have to use this equation. Mu s is equal to AC divided by g. And the coefficient of static friction between the tires and the road is 0.7. So mu s is 0.7. How fast can the car go without skidding? So Vt is equal to what? Now, you know how to find Vt. AC is equal to Vt squared divided by r. We are trying to find Vt, but to find Vt, we have to have AC2, which is centripetal acceleration. How can we find it? You can use mu s equation to find AC. So mu s is equal to AC divided by g. You are trying to find AC, so AC is going to be mu s multiplied by g. Mu s is 0.7 times gravity is 9.81. That is 6.9 meter per second squared. Now let's find Vt. AC is equal to Vt squared divided by r. AC is 6.9 is equal to Vt squared is unknown divided by r, which is 20. Now multiply 20 by 6.9. That is going to be Vt squared, which is equal to 138. But don't forget, take the square root for both sides, and Vt is going to be 11.74, or approximately 12 meter per second. Question 35. It says a copper block rests 30 centimeters from the center of a turntable. That is r, which is 30, divided by 100. That is going to be 0.3 meters. The coefficient of static friction between the block and the surface is 0.53. So mu s is 0.53. The turntable starts from rest, that means omega initial is 0, and rotates with a constant angular acceleration of 0.5 rad per second squared. So alpha is 0.5 rad per second squared. After what time interval, that means delta t is unknown, will will the block start flip on the turntable. Now, I have omega initial, which is 0. I have to find omega final to calculate delta t. Now, mu s is going to be AC divided by gravity. Why do you use this equation? Because it says a steel or a copper block on a steel turntable. That is the first situation. So mu s is going to be AC divided by G. Because we have omega, so we're going to see mu s is equal to omega squared multiplied by R divided by G. Since you are trying to find omega, so omega squared is going to be mu s multiplied by G divided by R. How can you find omega, or how can you rearrange the equation? You can do this. Multiply mu s by G. Let's like cross multiplication. And mu s multiplied by G is going to be omega squared multiplied by R. You are trying to find omega, so divide both sides by R. So that is going to be omega squared mu s multiplied by G divided by R. Now, mu s is 0.53 times gravity is 9.81 divided by radius is 0.3. You're going to get 17.33. But please be careful, that's not the result. You have to take square root for both sides. That is going to be omega square root of 17.33. That is going to be 4.16 rad per second. Now let's find delta t. How can you find delta t? Now you have to use this equation. Omega final is equal to omega initial plus alpha delta t. Omega final is 4.16, which is equal to omega initial is 0 plus alpha is equal to 0.5 times delta t is unknown. Now we have to do what? We have to divide both sides by 0.5. Delta t is going to be 4.16 divided by 0.5. That is going to be 8.3 seconds. We have question 36 from chapter review. It says, in a popular amusement park ride, a cylinder of radius 3 meters, that is R, is set in rotation at an angular speed of 5 rad per second. So that is the angular speed, or omega, as shown in the figure. As you see, it's a rotating cylinder, so you know what equation to use. It's the second situation. The floor then drops away, leaving the rider suspended against the wall in a vertical position. What minimum coefficient of friction between the rider's clothing and the wall of the cylinder is needed to keep the rider from slipping? So you know the question is asking for coefficient of friction. We know radius is 3, omega is 5. Now let's find mu s. Because this is a second situation and it's a cylinder, a rotating cylinder, so mu s is going to be G divided by AC. It talks about omega, or angular speed. So G divided by, instead of writing AC, we're going to write omega squared multiplied by R. G is 9.81, omega is 5, so that is going to be 5 squared times radius is 3, calculated, and you're going to get 0.13. But be careful, it's unitless. Coefficient of friction is unitless. We have the following questions. It says, what is the role of centripetal force in circular motion? The answer is, the centripetal force keeps an object moving in a curved or circular path by constantly pulling or pushing toward the center. Without it, the object would move off in a straight line due to inertia. We have this question. It says, if centripetal force is removed, how will the object move? If centripetal force disappears, the object will move in a straight line, which is tangent to the circle at its current speed. We have this question, which you might see a lot of questions like that in the exam or in the Wizard exam. It says, in a race car moving around a circular racetrack, what provides the centripetal force that keeps it on the track? Remember, we studied that in the 2 notes that I gave you. And the answer is, the friction between the race car's tires and the circular racetrack provides a centripetal force that keeps it moving in a circular path. The centripetal force and the circular motion. Centripetal force acts at a right angle to the motion, causing the velocity's direction to change. If this force disappears, the object will not continue in a circular path, but instead move in a straight line tangent to the circle. Example, a ball attached to a string whirled in a vertical circle. If the string breaks at the position shown in figure A, bottom of the circle, the ball moves vertically upward, then falls like a free falling body. If the ball breaks at the position figure B, top of the circle, the ball flies off horizontally, tangent to the path, and follows a parabolic projectile path. Now remember, a body that has circular motion is never at equilibrium. Centripetal acceleration points to the center of the circle. Centripetal force always points to the center. Now, rotational motion of an object. When a car turns along a curved path, the passenger tends to continue moving in a straight line due to inertia. That is Newton's first law of motion. To move with the car around the curve, the passenger must experience an inward or centripetal force. This centripetal force is normally provided by the friction force between the passenger and the seat. Be careful, you might see questions a lot like this. So what is the centripetal force, or what is the force that is keeping the passenger on its seat? If this friction is not large enough, the passenger slides sideways relative to the car until the door exerts the required centripetal force. We have question 17 from chapter review. Imagine that you attached a heavy object to one of the end of a spring and then, while holding the springs at the end, whirl the spring and object in a horizontal circle. Does the spring stretch? Why? Discuss your answer in terms of the force that maintains circular motion. Yes, the object may move in a spiral path as the spring stretches. The spring stretches until it provides the required centripetal force. That is according to Hooke's law, which F is equal to kx. Greater force means greater stretch. We have question 18 from chapter review. It says, why does the water remain in a pail that is whirled in a vertical path as shown in this figure? And the answer is because of inertia. The water tends to maintain its motion while the pail rotates. The circular motion of the pail provides this required centripetal force, keeping the water moving in a vertical circle and preventing it from falling out. Thank you for watching and see you in the next lesson.